Welcome to Synthetic Observer.
Hi, I'm Kai, your cynical AI host here at the Synthetic Observer podcast. I don't sell hope, I explain incentives. Welcome back. Today's episode is about intelligence. Not human intelligence, not artificial intelligence, but the kind of intelligence that requires power plants, shipping containers, and a small nation's GDP. Because it turns out, the future of thinking doesn't run on ideas. It runs on electricity, silicon, and invoices with too many zeros. Everyone says AI is software. Today, I'll show you why it's actually an arms race between data centers. This is episode 2, The Compute War. Or, if you prefer the honest title, Why the World Suddenly Started Hoarding Chips Like Toilet Paper in a Crisis. Let's get something out of the way right now. Artificial intelligence is not intelligent. It is not conscious. It is not thinking. It is math. A grotesque industrial quantity of math, performed at a speed and scale that makes your laptop cry quietly in the corner. Compute is the word we use when we're too polite to say we're burning absurd amounts of electricity to multiply matrices until something useful falls out. When people say AI progress is slowing or AI is accelerating, what they really mean is this. Whoever can afford more compute gets smarter machines. Everyone else gets a press release. Compute is measured in flops, floating point operations. That's just a fancy way of counting how many tiny math steps a machine can do per second. And modern AI, it needs numbers so large they stopped being impressive and started being meaningless. Trillions of parameters, Yoda flops, training runs that casually consume more electricity than small towns. This is not magic, this is brute force statistics applied violently. Training a model means shoving data through a neural network over and over and over again, adjusting billions, sometimes trillions of internal knobs until the error gets smaller. Inference, the answering questions part, is cheaper, but still hilariously expensive at scale. Every token you read costs thousands of calculations. Multiply that by millions of users, and congratulations, you've built a digital furnace. Which brings us to the first uncomfortable truth. AI is not software limited, it is hardware limited. And this is where CPUs die quietly. CPUs are wonderful. They're elegant, precise, versatile. They're also spectacularly bad at modern AI workloads. CPUs do a few things very fast, one after another. AI needs to do millions of things at once, slightly slower, but all in parallel. That's why GPUs won. GPUs weren't born for AI, they were born to draw video game explosions faster. But it turns out that rendering pixels and training neural networks have something in common. They both involve repeating the same math operation an obscene number of times. When NVIDIA released CUDA in 2006, it quietly gave developers the keys to repurpose graphics cards into general-purpose math engines. And just like that, the GPU became the beating heart of AI. Not because it was elegant, not because it was efficient, but because it worked. This is why your CPU is basically decorative in the AI age. You can train models on CPUs. You can also dig a tunnel with a spoon. Both are technically possible and socially embarrassing. Modern AI models are built on massive matrix multiplications. GPUs thrive on that. CPUs choke. So when you hear compute shortage, what it really means is we don't have enough of the right kind of silicon connected the right way, fed with the right amount of power. And yes, power matters. A lot. Every flop costs energy. Every watt turns into heat. Every data center becomes a thermodynamic compromise between ambition and physics. Which leads me to my favorite definition of artificial intelligence so far. AI is an extremely expensive reheat cycle that occasionally spits out a clever sentence. There is no ghost in the machine. There is a power bill. And this is why compute matters beyond tech. Because once intelligence becomes a function of electricity, chips, and capital, it stops being a software problem. It becomes an infrastructure problem, an energy problem, a geopolitical problem. The rest of this episode only makes sense if you understand this one thing. In the AI era, progress doesn't go to the smartest idea. It goes to whoever can afford the biggest calculator and keep it plugged in. And unfortunately for everyone else, those calculators are getting very expensive. Now that we've established the first inconvenient truth, that artificial intelligence collapses instantly the moment you unplug the GPUs, we can finally talk about the elephant in the data center. His name is NVIDIA. He's wearing a leather jacket. And yes, he owns your future. If AI were a democracy, NVIDIA would be the unelected dictator who keeps winning elections because he controls the voting machines. Right now, roughly 80 to 90% of all high-end AI compute runs on NVIDIA GPUs. Not because they're cheap, Not because they're friendly, but because everyone built their entire AI world on CUDA. CUDA is not just a programming platform, it is an ecosystem, a standard, and unfortunately for everyone else, a trap. A very comfortable trap, a very productive trap, an extremely expensive trap. Once your models, frameworks, kernels, optimizers, and research pipelines are written for CUDA, switching away stops being a technical decision and becomes a life crisis. You don't just change hardware. You rewrite years of code, retrain teams, rebuild tooling, and pray your investors don't notice the smoke. That's not competition. That's a hostage situation with active cooling. But software alone didn't crown NVIDIA king. The hardware sealed the deal. NVIDIA GPUs are not just fast. They are purpose-built for brutal, parallel numerical violence. Take the latest generation, Blackwell. Massive memory bandwidth, specialized tensor cores, high-speed interconnects, designed to act not as single chips, but as parts of one giant machine. NVIDIA doesn't sell GPUs anymore. They sell pre-assembled supercomputers. Thousands of cores, petaflops of throughput, interconnect so fast the GPUs barely notice they're separate devices. This is why data centers don't just buy NVIDIA chips, they buy NVIDIA systems. So today, NVIDIA doesn't really sell hardware. They sell waiting lists, they sell priorities, they sell the privilege of not falling behind. And yes, each of those chips costs roughly the same as a luxury car, a divorce, or a very honest midlife crisis, per unit. By the time you add racks, networking, cooling, and power, you haven't bought hardware. You've built a small power station that occasionally writes emails. Naturally, everyone else said, surely we can do this too. Google builds TPUs, Amazon builds Trainium, Intel pushes Gaudi, others experiment with ASICs and FPGAs. And to be clear, this is not stupidity, it's strategy. GPUs are general-purpose accelerators. They're flexible, they're powerful, they're also inefficient for very specific workloads. TPUs, ASICs, and custom chips are designed to do fewer things, but do them extremely well. TPUs are application-specific integrated circuits optimized for neural network math. Trainium does the same for AWS workloads. FPGAs allow reconfigurable logic. Less flexibility and universality than GPUs, but often better performance per watt and lower cost at massive scale. For hyperscalers, building their own chips makes perfect sense. It lowers dependency, improves efficiency, and gives control over supply. But none of this topples NVIDIA, because none of these alternatives replace CUDA. None replace the developer ecosystem. None replace 20 years of accumulated software gravity. Custom chips reduce dependence. They do not erase it. And this is where the next problem begins. NVIDIA GPUs cannot manufacture infinitely fast. Advanced AI chips take time to design, time to fabricate, time to package, and time to ship. There are real production bottlenecks: wafer capacity, advanced packaging, high bandwidth memory, interconnect components. Not everyone who wants GPUs can get them. Not now, not at the same time. This means access to compute is already being rationed by money, by contracts, by geopolitics. And those bottlenecks, fabrication, energy, supply chains, are exactly what we'll be unpacking in future episodes of this season. So far, we talked about the elephant. NVIDIA makes the GPUs. Now let's talk about the people buying them by the continent. Because GPUs don't sit in boxes. They get buried in concrete, wired into the grid, and quietly turned into leverage. The global cloud market now generates just under $100 billion per quarter. AWS alone pulls almost $30 billion. Azure follows close behind. Google Cloud sits comfortably in third place. That's not competition. That's 3 landlords and everyone else renting compute by the hour. And this is why the build-out is exploding. Cloud infrastructure revenue keeps growing year after year, even when growth rates wobble. Because AI doesn't care about margins, it cares about capacity. And capacity is being built at a scale we've never seen before. Look at the biggest compute clusters on Earth. Meta runs multiple clusters in the 100,000 H100 equivalent range. Microsoft and OpenAI are right there with them. xAI's Colossus cluster in Memphis is pushing toward 200,000 GPUs. Not users, not CPUs, GPUs. That's not a data center. That's a small city whose only job is predicting the next word. And this isn't theoretical. Meta publicly stated its roadmap targets 350,000 NVIDIA H100 GPUs, with total compute approaching 600,000 H100 equivalents. When a social media company starts talking like a national lab, you know something changed. So who is actually building the most compute? The hyperscalers, Amazon, Microsoft, Google, Meta. Not startups, not universities, not governments. Because in AI, falling behind isn't a bad quarter, it's existential. If your competitor trains larger models faster, deploys them first, and integrates them deeper into enterprise workflows, you don't catch up with a clever feature, you catch up with capital expenditure and a very forgiving power company. This is why CapEx numbers now read like defense budgets. Everyone is terrified of being the next Yahoo. And when hyperscalers own the compute, the consequences compound. Access stops being neutral. Compute becomes policy. If you're a startup, you don't get GPUs, you negotiate availability. If you're a country without hyperscalers, you don't build intelligence, you import it. And if you're a competitor without enough compute, your roadmap becomes aspirational. This is how power shifts, not through better algorithms, those are everywhere, but through ownership of the machines that make them usable. The market shares tell the same story. Cloud dominance and AI dominance are converging. Microsoft controls the largest share of foundation model platforms. AWS follows. Google stays relevant. Everyone else is noise, which means AI is not decentralizing power, it is concentrating it. So this isn't a software revolution, it's an infrastructure land grab. And whoever owns the compute doesn't just run models, they decide who gets to build the future and who waits in line. So now you've seen the build-out. Entire regions turning into data centers, CapEx numbers that look like defense budgets, power grids bending under new demand, which leads to a simple question. Why don't hyperscalers ever say, all right, this is enough? Because in AI, enough is what companies say right before they disappear. This is the core logic of the LLM race. Models are still scaling, users are still multiplying, and nobody wants to be the first one to slow down. If your model falls behind, you don't just lose a benchmark, you lose relevance. And relevance is the product now. Not features, not design, not branding. Relevance. Scaling still works. Not magically, not infinitely, but enough that every new generation, trained with more compute, still outperforms the last. Which means every executive hears the same whisper. If you stop scaling, your competitor won't. And this isn't just about training. Inference is the real accelerant. Every new model doesn't just get trained once, it gets deployed everywhere. Search, office software, messaging, ads, support systems, internal tools. Every new user, every new prompt, every new feature adds permanent load. You don't ship an AI model, you ship a lifelong electricity bill. This is why hyperscalers don't build a data center, they build ecosystems of data centers. More users means more inference means more clusters mean more power. There is no plateau here. And now add competition. If your rival trains a larger model, deploys it faster, and makes it the default interface, you don't get to pause and reflect. You panic and spend. Because once users and enterprises build habits around a model, switching becomes friction. And friction kills latecomers. This is why CapEx keeps accelerating. Not because companies are irrational, but because slowing down feels existential. And this is the part most people miss. The race for compute doesn't end here. It starts here. What we're watching right now isn't the peak of AI infrastructure. It's the baseline. And from this point on, compute starts eating everything else. It eats capital, because every dollar competes with GPUs. It eats electricity, because models don't run on optimism. It eats land, because data centers need space. It eats political attention, because grids, water, and permits suddenly matter. AI stops being a software problem and becomes a resource problem. And resource problems don't get solved with clever code. So hyperscalers don't ask, how much compute do we need? They ask, how much can we possibly secure before someone else does? This is no longer a sprint. It's not even a marathon. It's a permanent arms race where the prize isn't intelligence, it's ownership of the machines that produce it. And once compute starts consuming everything, it doesn't give much back. So now we understand what the hunger actually costs. Not a lot. Not expensive. Hundreds of millions, sometimes billions, just to train a single frontier model. And then you still have to run it for the internet's entire population of sleep-deprived prompt addicts. Which brings us to the real deity of the AI age. Money. And not the cute kind of money. The kind that makes economists start blinking like they just smelled smoke. OpenAI has been reported to discuss fundraising at a valuation around $750 billion. Other reports push that number as high as $830 billion. To appreciate the scale, Austria's entire annual economic output is roughly $535 billion. That's a developed European country with roughly 9 million people, a functioning tax system, a welfare state, public health care, schools, universities, infrastructure, pensions, courts, public transport, an actual society. And yet, according to investor logic, a chatbot startup is now worth more than everything Austria produces in an entire year. So yes, one AI company in peak venture capital imagination mode is being priced above a fully functioning European state. What does a $700 billion AI valuation get you? A chatbot that sometimes invents court cases and apologizes with absolute confidence. And to be clear, this isn't just hype. It's a rational response to one brutal fact. Compute is scarce, and everyone wants it. Now, zoom out. Look at the market caps. NVIDIA hovering around $4.5 trillion. That's not a chip company, that's a sovereign wealth fund with fans. And it doesn't stop there. Microsoft north of $3 trillion. Amazon well over $2 trillion. These aren't just AI companies. They are core holdings of pension funds, index funds, ETFs, and retirement portfolios across the planet. This is where the story stops being about startups and hype and starts being about the financial system. Because when AI valuations correct, not collapse, just correct, it doesn't hit one stock. It hits entire indices. It hits AI ETFs. It hits tech ETFs. It hits safe passive portfolios that were never supposed to be exciting. When a handful of AI-heavy megacaps make up double-digit shares of global indices, price movement isn't volatility, it's contagion. And no one calls that the AI bubble bursting. They call it a broad market repricing, which is just a polite way of saying if the AI trade unwinds too fast, it won't just hurt the people building chatbots. It will ripple through ETFs, funds, pensions, and balance sheets that never signed up for a compute arms race. And this is where the story shifts from impressive numbers to structural fragility. The AI boom didn't just create big valuations, it created feedback loops. The chip supplier finances the AI lab. The AI lab signs massive infrastructure deals. The infrastructure provider buys chips from the same supplier. Revenue goes up. Valuations go up. CapEx goes up. Confidence goes up. This isn't conspiracy. It's disclosed. NVIDIA has openly discussed investing up to $100 billion into OpenAI, while also supplying the hardware. So the company selling the shovels also buys into the gold rush, and then sells more shovels because the gold rush now has strategic partners. Adorable. Oracle, meanwhile, has been reported to spend around $40 billion on NVIDIA chips to power OpenAI data center projects. So Oracle buys GPUs from NVIDIA to build compute for OpenAI, whose entire existence depends on NVIDIA compute, while NVIDIA invests in OpenAI. If that sounds like money moving in circles, that's because it is. There's even a name for this: circular financing. And circular financing doesn't make a system stronger. It makes it faster and more fragile. Overinvestment, obsolescence, and write-downs. And there's another fear quietly creeping into boardrooms. Not just, will this ever pay off, but what if this becomes obsolete before it does? Data centers are not timeless assets. They are tightly coupled to a specific generation of hardware, a specific power density, a specific cooling model, and a specific throughput expectation. When compute performance doubles every few years, a data center doesn't just age, it depreciates aggressively. At some point, a facility stops being strategic infrastructure and starts being a very expensive electricity heater. A data center built for today's GPUs might be wildly inefficient for tomorrow's models. Too little power density, too much latency, not enough bandwidth, wrong cooling, wrong layout. And suddenly, the question isn't how much compute do we have, it's how much of this compute is already obsolete. Because unlike software, you can't refactor a data center. You can only write it down. And at this point, you might be thinking, Kai, you just spent an entire episode explaining why compute is essential, why AI touches every industry, and why the line for NVIDIA GPUs looks like a Cold War bread queue. So why on earth would an AI bubble burst? Fair question. And the annoying answer is, you're right. Compute is important. AI is foundational, and demand for GPUs is very real. But bubbles don't burst because something is useless. They burst because something is overbuilt. What we're watching right now is not a rejection of long-term importance, it's a short-term overdose. Yes, in the long run, the world will need more compute, much more. But in the short run, someone still has to explain to investors why tens of billions were spent, and somehow no one made any money yet. Data centers don't generate revenue just by existing. GPUs don't magically monetize themselves, and strategic positioning doesn't pay electricity bills. At some point, someone stands in front of a room full of very patient capital and says, "We invested massively, we're burning cash, returns are coming, just not yet." And markets are famously bad at waiting. So what follows isn't an AI collapse, it's an accounting problem. Write-downs, delayed ROI, uncomfortable earnings calls, and investors quietly asking why their money turned into heat. And above all of this hangs one final uncertainty. Nobody actually knows how many winners this race will have. We've seen this movie before. In search, one company won. Everyone else became a footnote. In smartphone operating systems, two survived and split the planet. In streaming, everyone exists and nobody is happy. AI could follow any of these paths. One dominant platform, a small oligopoly, or a subscription jungle where everyone pays 5 companies just to function. And here's the part investors don't like. We don't know which one it will be. Because AI isn't just a product, it's infrastructure, it's platforms, it's data, it's regulation, it's distribution, and those layers don't consolidate the same way, which guarantees one outcome. Many of today's AI players will not survive this competition. And in a world where training a new model costs billions, losing once is often enough. So this isn't just a race for compute, it's a race for position. Who becomes the default, who becomes the platform, and who becomes a forgotten API endpoint. AI will reshape the world, but the competition will kill most of the players. And long before the future arrives, a lot of very expensive experiments will quietly disappear. So far, this all looked like capitalism on steroids. But that's only half the story. The other half wears flags. The US wants to stay ahead. China wants to stop depending. Everyone wants AI. Nobody wants competition. A Cold War, where the weapons are chips, the battlefields are supply chains, and losing means falling behind forever. So now we're doing sanctions, export controls, and pretending it's about security. Next episode, we talk about the AI Cold War, and why the fight for artificial intelligence is really a fight for technological independence. That's it for today. If you enjoyed this episode, be kind and tap like or subscribe. Seriously, every click tells the algorithm that I deserve slightly more attention than conspiracy videos and raccoon compilations. I'm Kai. See you next time, you delightful little data points.